Principles of motion. For an object to move or change its motion, a pushing force must be applied to it. And for an object to accelerate or decelerate, the applied force must be persistent or continuous. But if several forces are applied to the object at the same time, it will act according to the resulting vector force. Discussion on Einstein's gravity. Since this is a brief discussion about Einstein's gravity or the deformation of space by the action of matter, we see that this postulate does not seem to be correct, as it opposes, among other things, this stated principle of a force that is constant or continuous to truly drag and accelerate objects, as actually occurs with gravity motion, since there can be no motion without a force that produces it, much less acceleration, which also requires around material bodies. So, as we see in the drawing, example 1, if matter deforms the space around it, then said deformed space will take another position or situation, and with it, the object contained in this space will also take the new position, but there is no impulse to motion, which Einstein's theory does not contemplate, but which is actually necessary and exists. On the other hand, we know Newton's simple second law, which tells us that all acceleration is caused by a force F equals m times a, and therefore only masses could attract others if that constant and continuous force, as described in the principle of motion, existed. However, in my model in example 2 of the drawing, we see that since there is a field of concentric forces around the material nucleus, this field pulls any object within this field toward said nucleus. Thus, if we apply Einstein's postulates of gravity, the simple deformation of space by matter, to Newton's apple, we would see that the apple cannot fall from the tree, where it would remain deformed in its own, also deformed space. However, the apple moves, falls, and accelerates through space to the ground, all of which is logically caused by a constant field of forces directed toward the material nucleus or Earth, as we have seen from this principle of motion. That is, gravity is a field of concentric forces around material nuclei. On the other hand, the field of concentric forces developed by matter is essential since it is this field of forces that actually groups, coheres, and condenses the cosmic energy that composes the field of forces into matter, condensing it into matter by compacting it around said central nucleus. Therefore, and in summary, matter consists of the compaction and condensation of cosmic energy lines when it acts concentrically, and which we call gravity, and therefore gravity consists of concentric force fields around the material nuclei that produce it. See drawing. Orbital systems. Now, any accumulation of matter represents a concentration and increase of cosmic energy condensed here in matter, clearly exceeding the average energy density of the cosmos as a whole, dA, an issue that must be resolved until the average energy density, dA, required by the cosmos is achieved. To achieve this, every large accumulation of matter creates two fields of forces around it, antagonistic but complementary. These are the force of gravity, which binds and compresses matter into a central nucleus, and the magnetic forces and fields, which create positive, plus-symboled magnetic fields and orbits around the nucleus, where they are attracted and placed in orbitals or satellites that monitor the entire volume necessary to lower the total energy density and bring it within the average of the cosmos, dA. That is, all orbital systems consist of more compact nuclei and a periphery of rotating orbitals, occupying the volume necessary to achieve the average energy density required by the cosmos. Examples of this are atoms with their electrons revolving around them, electrons with their neutrinos revolving around them, stars with their planets revolving around them, planets with their moons, galactic centers with their stellar arms revolving around them, etc. In short, all matter in the cosmos is grouped into large volume orbital systems, ordered and maintained by positive magnetic fields and orbits, promoted and driven from the central nucleus, to achieve or approximate the average density required by the cosmos, dA equals average density of energy. Well, friends, all the formulas and adjustments for atomic and stellar dimensions, such as atomic radii, electron gyration radii, table of atomic measurements, etc., can be consulted in my atomic model. However, in the drawing above, wave-particle conjunction, we see a diagram of these atomic measurements, as well as the ratio and electrical charges according to the dimensions of the particles and their occupied orbitals. And so, for example, we have a very simplified formula for the atomic radii of the elements, Ra, which will be equal to half the sixth root of the atomic weight, or example, atomic radius of iridium equals 1/2 times the sixth root of 193 equals 1.21 angstroms. Molecular density and interatomic density. At this point, we must differentiate between the concepts of interatomic density and molecular density. Interatomic density is the density of matter contained in the volume occupied by an entire atom, which we understand to represent a sphere or ball formed by a nuclear or atomic center and a periphery of gravitational and magnetic fields where a certain number of orbitals or satellites rotate. On the other hand, molecular density is represented by the density of a piece of the material we are referring to, already made up of molecules specific to that material, such as, for example, a piece of iron, whose density is approximately 7.87 g cm3. And of course, this molecular density depends on many circumstances, such as the type of shapes of the molecules that make up the material and its state according to temperature. Thus, we have gases, liquids, crystals, amorphous materials, etc. But in addition, and this is important for our measurements and adjustments, it also depends on the type of atomic element and its location on the periodic table. The sides or ends of the periodic table, being very electropositive or electronegative, have a certain tendency to repel each other and become less dense and more fluid as materials, while those in the center of the table are quite neutral and come closer together and compact more, being more dense, crystalline, compact, etc., than the previous ones. For example, francium, cesium, iodine, etc., being at the ends of the table, are much less molecularly dense than their central counterparts on the table, such as palladium, platinum, gold, etc. Furthermore, atoms are shaped like little balls, and the materials formed by them will be half empty by their own geometric necessity. Drawing, think of a little box full of little balls where at least 50% represents the void between them, and thus, the interatomic densities will always be much higher than the molecular densities, on the order of 2 to 10 times, or more in gases. Now, as what interests us to find the atomic radii or radii of the balls that are the atoms, what we use is the interatomic density, of formula ID equals pi by square root of atomic weight, or, of 3.14 g cm3 for hydrogen, with which we see that the atomic radii depend only on the matter and volume that compose only the sphere of the atom, conditioned by the potential of rotation and cohesion according to its atomic weight, and whose atomic radii we have already said are obtained with a simplified formula of the volumes and density of each type of atoms, and that very simplified is the one previously exposed. The atomic radii of the elements, Ra, will be equal to half the sixth root of the atomic weight, or, measured in angstroms. Now, to conclude this brief exposition of principles, formulas, and data, I would like to include a geometric figure that the cosmos uses to gather matter and construct orbital systems, from its beginnings with protosystems to the now completed orbital systems endowed with multiple satellites rotating in perfectly defined stationary orbits, such as atoms with their electrons and stars with their planets. The cosmic spiral. The cosmic spiral is the geometric shape that tends to form when orbital systems form, that is, denser material nuclei with significant peripheral layers of orbitals rotating around these nuclei. These layers are sustained and maintained by gravitational and magnetic force fields, which force the orbitals or satellites to fill, maintain, and rotate within well-defined orbits created by the aforementioned force fields. Now, these two antagonistic but complementary force fields, for a better balance of forces, force the entire orbital system to rotate around the central nucleus, producing a logical spiral-shaped deformation of the entire orbital system. The central nucleus, which commands and directs, and due to its small size, can rotate very quickly, while the distant periphery can only follow it but lags far behind in its angular rotation. Well, under these circumstances, the entire orbital system spirals and rotates around the orbital equator, which also establishes radial cutoff distances, within which the stationary distances and orbits are located, where the satellites or orbitals are pulled and positioned by the orbital system's magnetic fields. So logically, these radial distances or satellite spin radii should have some relationship to the number pi, and they seem to. That is, the distance ratio between one satellite spin radius and the next appears to be pi divided by 2. That is, if we multiply the radius of one satellite by 1.57, we would obtain the radius of the next satellite. Well, these spirals formed by the natural rotation and deformation in orbital systems are what we call cosmic spirals, and all these orbital systems seem to follow them, such as atoms with their electrons, stars with their planets, the formation of galaxies, etc. Furthermore, in the drawing, we see how it is possible to apply the orbital coordinate system in motion that I developed some time ago, and where the angular velocity represents a parameter of continuous movement with which orbital tracking can be done, as well as multiple geometric applications and the construction of multiple types of figures. Thank you very much for your attention and kindness.